Hello, this is a follow-up to the previous video. I got the problem fixed and I can show you where I made the mistakes. There was one that was down here. One of the decrement D's was accidentally written as a decrement C. I think it's either this one or this one. I think that one was in the previous video, so it was already there. And then the second problem was a little bit more insidious. Let me show you what I did and why it is a tough one to fix or find in the first place. So apparently, when I switched between the windows, there was one time that I switched back to the spreadsheet and in the source tab. So when I was in the source tab, for whatever reason, the cursor was on this line and I pressed the delete key. So this instruction was basically not there. And then I assembled the program and then downloaded the program um, uh, into LogicSim. And that program didn't work. And the way it didn't work was the first time it tried to return, it returned to some kind of really bogus location. And then at some point, it just restarted the program from the beginning. And that's what we saw at the last part of the previous video. So as it turned out, it was because this instruction was entirely missing because I probably pressed the delete key in the wrong window and this particular instruction disappeared. So why would that give me the symptom that it gave me? Well, it's rather simple because I still have this instruction here to reclaim the spot of the return address, but I'm not putting it into register B. So by the time we return through register B, this register B is going to have whatever register B is going to have from earlier calculations. So if we figure out, what we do with register B, this is the last time we use register B. And obviously, this is before the function call to return from traverse right. Um, but all the recursive versions is going to have this one as the last instruction. So as we return, it is it's register B is going to have that particular value, which is the R member of a particular. Let's see, it's the R member of a particular node. Okay, there we go. And the way I fixed this problem was also because I used the log. So the log was actually quite helpful. Let me show you the log. Oh, I have it in the browser, so give me a second here. So here's the log. And what I found out was, from when the PC, this is the program counter. So if I go all the way back to here, this is the program counter and this is the stack pointer. So as I track down the program counter, I look for anomaly, which is here. So it returned from 66 to location FF. So it was using FF as a return address, and that's why it got back there. And then whatever is in FF, is probably not even a valid instruction, which means it is the same thing as a no op. And because it's a no op, it followed right through to location 00. So the whole program just restarted. So whatever was in BB was in register B was FF. And so that may not be here. Okay, let's see. Why would register B have the value of FF? I'm just going through the recursive call here because it's just being a little bit obsessive at this point because the program is definitely not working. Um, yeah, so B is supposed to be the right member of the structure pointed to by PTR before the recursive call, and then register B did not get used for anything else. This is the call, assuming we are not performing a recursion. And this is what we do when we skip the recursion. So it skipped all the way to here. and then B is not initialized correctly, and then we decrement the stack pointer and then jump based on B, which means B would still be retaining the value from the last time we use B in the recursive call, which is supposed to be here. But it's quite obvious that B is getting FF, as array. So that's the part that I don't really quite get, because this is where we use B to push array on the stack, and that's what put the FF on the stack. And that's also how B can potentially get the value of FF. But there's additional code after this to put other values into B, which is the member R of the structure pointed to by PTR. And that was the last thing that we put into B. So the log is not consistent with this observation of how it got from the JMP instruction all the way back to FF. Oh, the other thing that is interesting about this was the PC, the program counter, was never changed to the location of the LD instruction that was supposed to be there, but it was not. So that's how I spotted that problem. Go like, okay, let's check here. Why am I not putting something into register B before we do a JMPB? As it turns out, that entire instruction, which is let's see here, was missing from the source, so that's why it wasn't working. So anyway, the program is done. I am going to upload it so that you guys can study it. All right, so that's basically the solution to the homework assignment. Okay, the next thing I want to talk about is how to get ready or how to prepare for the final exam. So this particular final exam is focusing mostly on the material after the second exam. And I'm going to finish grading the entire second exam today so that we all have a pretty firm understanding of how we stand in class at this point. So the idea of studying for this exam is to start with the assignments, start with especially the recursive assignments, and also start with the code that I did in class. If you're in the Monday, Wednesday class, it doesn't hurt to check the lectures of the Tuesday, Thursday, and vice versa. And that is because sometimes I do slightly different sample programs in the two classes. So it might be helpful to kind of just get an idea of what I talk about in the other class. Or for the same sample program, I can do it in slightly different ways. So that may be helpful as well. But this particular program here, using structures and recursion and stuff like that, is particularly useful. One thing that you might want to do is to get rid of all the comments. Just get rid of the comments, strip the comments, and then go back in and see if you understand how this code works. Okay, so that's one thing you can do. And I can let me show you how we can do that in VI. So let me get out of mousepad first, and then we switch back to, oops, VI. Okay. So let me first make a copy of this one to, oh, okay. My computer just got stuck for a moment, which is kind of strange. So anyway, I'm going to copy this one to solution.ttpasm. So this way I can modify the original one and get rid of all the comments. All right, so this is a substitution line that's looking for a slash followed by another slash and then followed by any number of additional characters and replace everything with nothing, and it applies to all the lines. So you can see how all of those are now removed. So this program is still the same program. It's just that all the comments are gone. Okay, so I'm going to zip this up along with the solution. Okay, so zip. Um, all right, and then I upload it to each class. And so the first thing you can do is to look at this code and figure out how it works. Okay. Um, and then the second thing you can do is to what is involved to change the structure. In other words, if I go back to the C program and I say I want to change the value to be the third member, okay, and so this means every single member is reordered, the position is changed. So you have to now look at this and go like, okay, so what do we do to change the code? So if I do something like this, oops, okay, like this. The first thing, obviously, that we have to change is down here, which is how we initialize the nodes. And all of these equivalent lines in the assembly has to be changed as well. But then you also have to change, every single time we access a member, such as this line, and this line, all of those lines would need to be changed as well. And so your exercise is going to involve to find out what the assembly code is doing on each line, and on top of that, how do we adjust for accessing different members of a structure that is pointed to by a pointer, and the pointer is being passed as a parameter. So that would be helpful because this is going to force you to understand the code that I have. Okay, I'm not gonna save this one. I'll leave it the way it is. And then going through all the sample programs that we have done in class is going to be helpful too. Instead of just listening to the lecture, you might want to just kind of copy the code and then see if you can annotate the code in your own words to figure out what each instruction is doing in order to accomplish what the entire program is supposed to do. So that would be quite helpful. And in doing so, you might want to identify certain rules. I have started on that a few days ago, right before the semester ended. So when you go back to the shared folder, um, not the exam possibilities. Let's see, where did I put it? I think I might have put it into old. Nope, not that. Um, pretty sure I created a file that talks about the convention. Can't seem to find it, but I was pretty sure that I did it. Okay, let me see if I can still find it. Okay, that was in here. Hmm. Anyway. Hmm. Okay, so if I can find it, it would be great. If not, uh, you can do it yourself. So the idea is to go through the code, okay? Just go through every single sample program that I have written. And then the idea is to go through it and um, look at each line and ask, what does this, what is this doing, and what is the convention that we are using when we translate the program from C to C++. And that's the idea. So that would involve how we push parameters on the stack, which typically involves storing something to where the stack pointer points to, right after we decrement the stack. This is how we push something. But what are we pushing and in what order? And how does that relate to the convention in C? Okay, so that's one. Basically, anything that has to do with the stack pointer is going to be important. Like these two increments, why are they here? What are they doing? What convention of C are we implementing here? Register A can be helpful, can be useful, especially at the end of a subroutine, why do we put a value into A, um, and so on. In this case, we are not putting something into A per se. We're actually adjusting the stack pointer by a big chunk. So now the question is, why are we doing that? These are equivalent to the structure, initialized structures. Why are we putting these values in this particular order? Um, exactly what is this byte and2, what is being put into that particular byte location. You can see all of this in logisim, by the way, because it's statically defined. So that would be another way to kind of gain an insight of what the program does. And then when we get to traverse, um, same thing. Why are we interested in the stack pointer? In other words, all of these instructions originate from the stack pointer because that's how we started from the stack pointer. But eventually we end up with something that we are checking to see whether it is zero or not. So what are we exactly checking? Are we checking whether a parameter is null? Are we checking whether the address of a parameter is null? Or are we checking what the parameter is pointing is at is null? Those are the kind of questions that you really should ask as you go through this code. Um, and then just throughout this code here, every time we do something with C or a register that was copied from the stack pointer, you kind of have to ask the question, what are we accessing from the stack? Is it a parameter? Is it a local variable? And so on and so forth. Um, and then every time we do a dereference, which basically includes everything that has a parentheses around it, so that can be an LD or ST instruction, you have to ask the question, where in memory am I accessing and why is that important? So in this case, are we accessing a parameter? Are we accessing what a parameter is pointing to, or what? Okay, so those are the kind of questions that you really should be able to answer. So let's move down and see what else is here. When we see sequences of dereferencing, such as this or this, then you